Okay, so we are talking about another way we can express concentration. We've already talked about molarity. We've already talked about parts per million, and now we have molality. So molality also has moles in it, but it's a little bit different. So the formula is the number of moles of solute. So that's the same as molarity, but instead of we had liters of solution. Now we have kilograms of just the solvent. Okay, so the last time we talked about this had both the solute and solvent together as solution in our denominator. And now we have simply, it's a ratio of solute to solvent. So I'm going to include that. It's a ratio of solute to solvent. Okay, so our units, once again, we're going to use something, it's not going to be moles per kilogram. It's going to be little m, lowercase m, and it's pronounced molal. So instead of molar, we're going to be using molal. So let's move down. So there it is, molal. Here is our calculation. So 0.25 moles of sugar is dissolved in 0.50 kilograms of solvent. Doesn't specify which sugar, doesn't specify, which solvent, but that's okay. What is molality? We don't actually care right now because all it is moles of solute, which is 0.25, and it is kilograms solvent, which is 0.50. So let's see. This is embarrassing, but if we're going to maintain our sig figs, it would be 2 sig figs, 2 sig figs, 2 sig figs. Units would be little m, which would be pronounced molal. What's important to remember also, so if you need moles, but you're given grams to moles, you would divide by your GFM. So that's important if you are given grams. Now let's say you're given grams of solvent and you need kilograms of solvent. That's going to be dividing by 1,000, which is the same as moving your decimal place 3 spots to the left. Okay, so this formula is not on the reference table, but it's pretty straightforward. Thank you.